Blockchain technology has been touted as one of the most secure ways to store and transfer data, thanks to its decentralized and immutable nature. However, like any technology, it is not foolproof, and security breaches can still occur. In this video, we'll discuss some of the key security principles that underpin blockchain technology. The first principle is encryption. Encryption ensures that data stored on the blockchain is secure and cannot be accessed by unauthorized parties. This is achieved through the use of cryptographic algorithms that scramble the data in a way that can only be decoded by authorized parties with the correct keys. The second principle is decentralization. Unlike traditional databases, which are typically centralized, blockchains are decentralized, which means that there is no single point of failure or control. This makes it much harder for hackers to launch attacks and compromise the security of the blockchain. The third principle is consensus. Consensus refers to the process by which nodes on the blockchain network agree on the validity of transactions. This is typically achieved through a consensus algorithm, which ensures that all nodes are in agreement before a transaction can be added to the blockchain. This makes it much harder for bad actors to manipulate the data on the blockchain. The fourth principle is immutability. Once a transaction has been added to the blockchain, it cannot be changed or deleted. This means that the data on the blockchain is permanent and cannot be altered, providing an extra layer of security against tampering and fraud. The fifth principle is transparency. One of the benefits of blockchain technology is that it is transparent, which means that anyone can view the data on the blockchain. This can help to prevent fraud and corruption, as it allows for greater accountability and transparency. Finally, it is important to note that blockchain security is not just about technology, but also about governance and best practices. This includes things like ensuring that access to the blockchain is limited to authorized parties, regularly updating and patching software to address vulnerabilities, and providing adequate training and resources for users. In conclusion, blockchain technology is highly secure thanks to its encryption, decentralization, consensus, immutability, and transparency. However, it is important to approach blockchain security holistically, taking into account governance, best practices, and ongoing monitoring and improvement. By doing so, we can ensure that blockchain technology continues to be a secure and reliable way to store and transfer data.